let's see.
And the others are just, just huge.
Let's jump into it.
I know, right?
How are the midterm grades?
I haven't even started grading your class yet. I gave a bunch of tests. All my classes got tests. I'm grading others first. But I'm optimistic. We'll see. We shall see. Because everyone I spoke to, it's grade 1. Everyone was like, okay, so last time, long time ago, we saw something called Pythagoras' theorem. So if you have a right triangle where this side length is A, that side length is B, that side length is C, where C is called a hypotenuse. Then A squared plus B squared is equal to C squared. That's called Pythagoras' theorem. Gives us the relationship between the side lengths of a right triangle. It's a very important relationship. We are actually going to figure out a lot of things based on this equation right here. Starting with, I think that's what I jumped into first, I think. Yes. Starting with, so now we also introduce the plane. Just a contraption that looks like this, invented by René Descartes around the 1700s, in which case we could start to plot and draw pictures of equations, which was very revolutionary, let's say. So now what we want, now let's figure out distances in the plane. So the plane, you can think of it as an environment. If you have two things in the plane, you're going to want to know how far away they are from each other in some circumstances. So we remember how we could plot coordinates here. We can have, let's say, an x coordinate, call that x1, and it can have a corresponding y coordinate, call that y1. So this thing here, we can denote it x1 comma y1. We can have another number along the x, call it x2, corresponding number along the y, call it y2. And so we can have the point x2 comma y2. So the first coordinate tells you the number that's on the horizontal, the second coordinate tells you the number that's on the vertical, and we care about this distance here, d. Now, one thing you can notice is that we can actually fill in a horizontal line and a vertical line. And in fact, we know what the distances of these are. The distance between these two numbers is going to give you the length of the base, so that's going to be x2 minus x1. And the distances between these two numbers is going to give you the height. So that is going to be y2 minus y1. And then we apply Pythagoras' theorem. So Pythagoras' theorem says d squared is going to be equal to this squared plus that squared. So it's going to be x2 minus x1 squared plus y2 minus y1 squared. And so d, which we're taking to be a positive distance, so we're going to take the positive square root, is this formula, x2 minus x1 squared plus y2 minus y1 squared. Very important formula. It tells us the distance between the coordinates x1, y1, and x2, y2. It is called the distance formula. And that is the distance between x1, y1 and x2, y2 is given by. So this is just something we know now. This is another thing to memorize. So it'll be on the next quiz. You need to know this formula. Technically the order doesn't matter here because you're going to square things, so if one is negative versus positive, it's not going to matter. So we're going to square things and take the square root. That's going to give us a non-negative number. It's going to be significantly bigger all the time. And so that is the distance formula. So knowing distances is an important thing to do that formula. Here's another thing that's going to be important for various reasons, including the next thing I'm going to talk about right after I talk about this thing, is finding midpoints. So, again, if I have a coordinate x1, y1, and another coordinate x2, y2, and we wish to find the point that is exactly in the middle, halfway between these 2 points. So this is the midpoint. How would you actually figure out the location of that point? Well, one thing you can notice is you can start to construct things again by constructing, say, a horizontal and a vertical, horizontal and a vertical. And because it's a midpoint, you have to be halfway between the x coordinates and halfway between the y coordinates. So that's what we're going to use. We are going to call this point, we don't know what it is, call it x comma y. What you would notice is that this distance here is going to be the horizontal, so this is at x, this is at location x1, this is at location x2, this is at location y1, this is at location y, this is at location y2. So the distance between these is x minus x1. I can also measure the distance between this, that's x2 minus x. I can measure the distance between this is y2 minus y. And I can measure the distance between here, that's going to be y minus y1. And so now for the midpoints, these two must be the same so that you're midway between the x values. These two must also be the same, so you're midway between the y values. This means that your x minus x1 must be equal to x2 minus x, and your y2 minus y must be equal to y minus y1. Here, decide to solve for x, bring the x over, I get 2x, bring that over, I get x1 plus x2, and so the x coordinate is going to be x1 plus x2 all over 2. Similarly, the y coordinate is going to be y1 plus y2 all over 2. And that leads to what we call the midpoint formula. Again, it's something you have to memorize. The midpoint, the lines segment connecting x1, y1, and x2, y2 is given by the coordinate is going to be, the x coordinate is going to be x1 plus x2 over 2. In other words, you take the average of the x coordinates, and the y coordinate is going to be y1 plus y2 all over 2. In other words, find the average of the y coordinates. This gives you the formula for the midpoint between 2 points. Let's do an example. So you need to know the formulas, you don't need to know how to derive them, but I just thought I'd show you that they didn't come out of nowhere. And I find the midpoint between those two. So, distance. I don't want to spend too much time here. Let's just set x1. You can call either point x1, y1 you want, the other one x2, y2, and x2, y2 equal 4 minus 7. Then the distance between them is going to be the square root. x2 minus x1 squared plus y2 minus y1 squared. Keep writing down the formula until you have it memorized. So x2 is 4 minus x1 is 2. y2 is minus 7 minus y1. So that would just become 2 squared plus 8 squared, which is the square root of 68. Which you could simplify, you could factor out. So the distance between those, it's radical 68 units long. I want to find the midpoint between those. The same thing, define x1, y1 to be this. The midpoint is going to be x1 plus x2 over 2, y1 plus y2 over 2. x1 is 2, x2 is 4, y1 is 1, y2 is minus 7. That's going to be 6 over 2, which is 3. It's going to be minus 6 over 2, which is minus 3. So, basically what we've just discovered we're at the points 2, 1. And we have the points 4, -7. Then connecting those with a line, the length of that line is going to be radical 68 units. And the point smack dab in the middle is going to be 3, -3. And we have that by Pythagoras system. Questions so far? Good, we've all seen this, right? Let's look at something else that we've probably all seen already, just to remind you about it. We have circles. So, a circle is a set of points equidistant from some reference point called the center of the circle. The common distance of the points, this distance that I'm referring to here, is called the radius of the circle. We want to be able to express this as a formula. Sometimes we might need to set up a circle. Sometimes we need to know when we're looking at the formula of a circle. The formula for such points. Let's see what we are talking about here. So this is just an example to illustrate what we're going to do. So there's some point here in space, call that the center of the circle. And let's call this coordinate h, k, which is typically the unit. Now what we're doing here is we're measuring all points that are a certain distance from this circle. So from a certain distance from this point. So you're going to create an object that should look, it's not going to be perfect, but you're going to create an object that looks like this. And the idea is, if you were to measure the distance from this to any of the points, it'll always give you the same distance, right? This is what creates a circle. So that's the center. The distance d, that's called the radius. The distance here, it's called r for the radius. So we have from this point to any point out here on the edge, we say it's a distance r away. So how do we find all such points? Well, you give them a name, call it x, y, where x and y can just change coordinates as needed. And so what we would notice is that by the distance formula, r is going to be the distance between xy and hk, which is going to be, by our formula, the square root of x minus h squared plus y minus k squared. In other words, your r squared is going to be if I square both sides, that guy, that's, turns out, is the equation of a circle. That equation will give you all points on that red outer rim. So this leads to the equation of a circle. Something else for you to memorize. So the circle with center h comma k and radius r is given by this equation: x minus h squared plus y minus k squared equals r squared. That's just something that we know now. We knew it once upon a time, now we remember. Yeah, this class is going to be a lot about stuff that we knew once upon a time. Make sure we remember. I even talk about equations of lines by the end of class, which most of you probably remember, but I'm going to go over it anyway. So, sometimes a circle can be given in a form that's not like this, like it's multiplied out. So in such a form, we can use completing the square. So here's why you need to know completing the square, even though you're not going to use the solve quadratic. And you'll need it later on in Calc 1 and Calc 2 for deriving all sorts of things as well. You can use completing the square, which I described to you previously. Write it in the above form. And determine the center and radius, which is going to help you understand the circle a little bit more. Nothing else to teach you here. I gave you the formula and I already spoke about completing the square, so let's just jump into 7 examples. So there were examples similar to this on the test in the bonus problem. So I guess if anyone attempted that now, they'll actually be able to know if they were right. Examples. Find the center and radius. Let's see of the following. I think the one on the test kind of looked like this here. It's not that same example, but it looks similar. So, worst case scenario, this is an exercise in completing the square. See if you know how to complete the square. Okay, how do we do A? Yeah?
Well, first, if you want to, you can write down the formula and just look at like what is substituted in this
Mhm.
column.
And?
And then since the center is HK,
Mm-hmm.
it would be H is 1. And K would be -2. And since it's the radius squared, I believe the radius is 2.
Yeah, that's it. So the 4 here you just write as 2 squared, and so that is going to be the R. That one was easy. Okay, B. Yeah,
The center should be 0, 0.
right, because you can think of x squared as x minus 0 squared. And you can think of the y squared as the y minus 0 squared. And so the center here is 0, 0. This circle is centered at the origin. Radius? Square root of 3. Because again, you can think of this as the square root of 3 squared. Okay, those are just see if you can read the formula. That's basically it. Nothing much to do there. However, with problem C, things start to get a little bit interesting. Okay, so tell me how we're going to figure this one out.
Group all the x's and the y's.
Love how you're talking in strategies. Okay, this is what I'm going to do. I'm going to group these guys. Okay, group x's and y's. That's going to be the first order of business. So x squared minus 2x, put the x's beside each other. Y squared plus 4y, put the y's beside each other. The other guys I can move to the other side. Move everyone else to the other side. Which it's already on the other side. Okay, what do we do?
So we have like x squared minus 2x, which is the beginning of the square.
How do we complete it?
Divide b and square it. But divide b by 2 and then square it.
So you get minus 1 and then you square it. So you're going to add minus 1 squared. And now normally there's an equation, you can add minus 1 squared to both sides. I'd probably rather you guys add and subtract in the same location for now. There's going to come a point in Calc 2 where you're going to need to complete the square, but you're not going to have an equation with which to do it. You have to kind of complete the square in the current location, and that's how you would actually do it. So yes, you can think adding on both sides, but it's think of adding and subtracting probably would be nicer for the future. Now, you're going to do the same thing here. You take half the coefficient of y, which is 2, and you square it, and you subtract it. Now, when you do that, the first 3 terms will be the complete square. It's going to be x plus the guy inside the parentheses, which is a minus 1, all squared. I'm going to have a minus 1 left over here, plus these first 3 terms is going to be a complete square. It's the y plus the guy inside the parentheses, so it's y and a positive 2, all squared. And I'm going to have a minus 4 left over here. what I can now do is I can bring the -1 and the -4 to the other side by adding 5. That is going to give us x minus 1 squared plus y plus 2 squared equals 4. And it's the same, it's actually the same as the other one. So the center is 1 minus 2, radius is 2. That was just an expanded form of this. Yeah.
Can you explain again why you had both -1s and then both 2s on the side? The green part?
Well, we learned when we were completing the square that the constant term was always a half of this square.
Oh, so it's just half.
Right. You just take a half of that. So you divide the -2 by 2, you get -1, you square it. Now you added that, so you change the value, so what you have to do is subtract it again. So you're actually adding 0 in a very convenient way. Similarly here, half of 4 is 2, take the 2 and you square it. So you add a half of the coefficient of the linear term squared. Add and subtract that. The first 3 terms will always be a complete square in that scenario. It's going to be the variable plus the guy inside the parentheses all squared. It'll happen automatically. Yeah, you could see that you could factor this to do that, but don't waste your time. It's just that plus that squared, all squared. So we kind of force that to happen. Okay, D, 2x squared plus 2y squared equals 6x minus 10y minus 9. Okay, how do you do this one?
Bring everything on one side. -6x and 10y on one side.
Yeah, so minus 6x squared just beside the x plus 2y squared plus 10y.
Can't you divide by 2? Because on the left side, they're all division 2. So
You can divide through by 2, because to complete the square you need the coefficient to be 1. There are scenarios where you can factor the 2 and complete the square inside the parentheses. I'll let you deal with that when you get to it. It's not going to be too crazy. But yeah, you could just divide through by 2 here. That's going to give you x squared minus 3x plus y squared plus 5y equals minus 9 over 2. And now what? Now what? Well, they're already grouped. We have the x's here and the y's here. What do we do with them?
just be x minus 3 divided by 2.
We're going to add minus 3 over 2 squared, subtract minus 3 over 2 squared. We're going to add 5 over 2 squared minus 5 over 2 squared. First 3, complete square, x minus 3 over 2 squared. Here I'm going to be left over with a 9 over 4, plus these guys will be a complete square, y plus 5 over 2 squared, minus 25 over 4. Bring those guys over, so it's x minus 3 over 2 squared plus y plus 5 over 2 squared equals minus 9 over 2 plus 9 over 4 plus 25 over 4. So this is going to be minus 9 over 4 plus 25 over 4, which gives you what? Huh? 16 over 4, which is just 4. So we end up with x minus 3 over 2 squared, y plus 5 over 2 squared equals 4. Center. Three over 2 minus 5 over 2, because negative is in our formula, so and the radius is 2. Let's get the this. So we spent a lot of time on the basics, factoring, simplifying, knowing how to multiply, knowing how to divide, knowing all that good stuff like completing the square. Now for a while we're just going to be applying all these skills that we know in very special circumstances. Figuring out the center and radius of a circle is a special circumstance where you can apply completing the square, as well as knowing how to add fractions and whatever. Questions? Yeah, and when it comes to things like these, it's going to be very similar problems to this that I would ask. Give you a random equation, tell me what's the center radius of this circle. The other situation, which I don't think I have any examples like that here, could be something like, which I'll probably throw those in your homework, but another common type of problem you can probably expect to see at some point. Is them telling you something like this: the end points of the diameter, just not necessarily the end points of the diameter of a circle are let's do the guy we saw earlier. 2, 1, and it was 4 minus 7. Find the equation of the circle. State its center and radius. How do you actually do this one? Ideas for the plan of attack. Yeah, so we saw this last time. It was like 2, 1, and then connected down here was 4, minus 7, and we actually found the length of this whole thing. So we previously found that this was radical of 68. Okay. So if we didn't find it, we would find it. The other thing that we would also have found is the center, the midpoint between these two, which we did. That was 3, minus 3. Okay. So if they give you 2 points that they tell you lie on the edge of the diameter, what that means is the circle is actually just connecting these two things here. And so you need to get to the midpoint of those guys to find the radius, to find the center, and then the radius is just going to be half the distance between these two. So what you would have is center is 3 minus 3, radius is radical 68 over 2. And so this would mean the equation of this circle x minus 3 squared plus y plus 3 squared equals 68 over 4. Does 4 go into 68? Yeah. X minus 3 squared plus 3 squared equals 17. That would be the equation. And the center and radius would be this. So in terms of circles, that's like the worst that's going to happen. Not going to embarrass anybody by asking them to draw a circle, because that's what a circle is going to be like looking like a potato or something. So you would either be given a circle in expanding form and you need to use completing the square to contract it, or I'll do something like give you some points on the circle and you need to use distance formula and midpoints to figure out how to construct the circle. That can come in handy in several situations. Anything else I want to talk about here? Well, this section goes into graphing a little bit, but I'd rather deal with that later. Because they teach you how to graph by plotting points. It's like, this is in high school. Are more efficient now. We're grown-ups. So let's move to another. It's so funny. Sometimes I'm in like Calc 2 and I see someone like plotting a bunch of points to be able to draw something. Like, come on. You do have to plot some points, but not like 50 of them. You really don't know what you're doing. So we'll cover graphing and efficient ways to actually do it, because for so many things, just being able to do a quick sketch is going to be so important to the problem solving process. It's not even funny. You spend like half an hour just drawing the picture, it's not going to help you very much. Let's talk about lines. Also something that is way more important than you would think. 2/3 of Calculus 1 is all about lines. That's all it's about. As an idea. Like, specifically, no, you'll be doing a lot of stuff in Calc 1, but a big part of it is being able to draw things that we call tangent lines and taking advantage of the properties of such lines. So lines, very important. Let's remind ourselves of the basics. So, the line, it's of course a straight line. This is just something that has, we claim, constant steepness. This is a graph with constant steepness. So at any point, if you know how fast it's rising, you know how fast it's rising at all points. It's always going to be rising at the same speed. So what happens is if you move to the right and then up, you take the ratio of these two things, you'll always have the same thing, no matter where along the line you actually do this. That's what makes something a line. If something is not a line, that's not going to be true. So to measure the steepness, we define something called the slope of the line, which we define to be how far we rise over how far we ran. So the horizontal is called the run, and the vertical is called the rise. And the slope is the ratio, rise over run. For a straight line, this will always be the same. For anything that's not straight, it's not going to be the same. So if you have something, we'll talk about curves that look like this pretty soon. You notice that if you take the ratio here, it's going to be very different from the ratio there because it's not straight. Straight lines are the only thing where that rise over run is always going to be the same number. Now, of course, we can actually measure this. So you can pinpoint two things, coordinates here. Call this x1, y1. Call this x2, y2. And so the rise is going to be given by y2 minus y1. The run is going to be given by the distance between the x coordinates, x2 minus x1. And so you end up with the slope equals y2 minus y1 over x2 minus x1. And this is often denoted n. Leads us to the first important equation, the slope m of a line connecting or passing through. If you have just, it doesn't go on forever, we call it a line segment. But the line will pass through these 2 points and go on forever, passing through x1, y1, and x2, y2 is given by n equals y2 minus y1 over x2 minus x1. That's the important formula. Of course, something is important to know that that's how you get the slope. How do we get to the equation of a line? Right, so to get the equation, what you do is you vary the x2, y2. So we have our line doing its thing. We fix 2 points, x1, y1, and x2, y2. But then we said, let's not make that a specific point. Let's call this x and y. Allow this point to move. Right? So it's a variable now. I can change my x and y and run it along this line. And so this means that the slope is going to be y2 minus y1 over x2 minus x1. In other words, this is going to be y minus y1 over x minus x1. Or we get y minus y1 equals mx minus x1. This is the equation of a line. It gives you the x and y coordinate for a line passing through x1, y1 with slope m. This is called the point slope form for the equation of a line. And as the name suggests, use when you know a point and the slope. Of course, if you know 2 points on the line, you can actually create the slope and then use either one to get to that. But this is called the point slope form for the equation of a line. Oftentimes, a point of interest is going to be the y-intercept. intercept is a point of interest. Right, figuring out what the y value is when x is 0 is important for lines, but it's important for other things as well. So let's say I go through this coordinate here. So let's make sure my x1, y1 is specifically a coordinate, let's call it 0, b, which is the standard. This is called the y-intercept, where line crosses y-axis. Give that point a name, call it 0, b. And of course, over here, I still have my x, y. So, plugging in 0, b for x1, y1 in the above formula, the one I just wrote in the box. You would end up with another equation for a line. So you'd end up with, I'm going to put y minus b, because my y1 is now the b, equals mx minus 0, because my x is now the 0. That is of course equal to mx, and so this means I get y equals mx plus b. And this is another form of a line. It is called the slope-intercept form. So we can have lines in different flavors. Sometimes we'll expand all the brackets, we'll bring the x and y to one side, and then we'll multiply through by a number to clear all the denominators to get it in this form. And this form here is called the standard form for the line. It's called the standard form because it fits in line with another set of formulas that's more overarching. But really when it comes to lines, you're going to be using one of these two equations most of the time. But if you're given something like this, you should recognize that you're looking at the equation of a line. Here, A, B, not, both 0. Which brings us to the other situation. What if we had a 0 for B? Does that actually mess things up? Well, the B here is not the y-intercept, so don't get confused by that. Not the y-intercept. Should I probably put that in red? Never mind. So we know the equation of lines. Let's look at some other flavors that we can have. The above formulas work for non-vertical lines. general, we have the following. So, we can have a line that is doing something like this, going up as we move from left to right, and this is going to be, it's going to look like something like y equals mx plus b, where m is positive. Right? So if your m is positive, you're moving up as you go from left to right. Another scenario that you can have is the line is moving down as you go from left to right, and you can write this equation as y equals mx plus b, where m is negative. We have a situation here where the line is actually parallel, I'll talk about what parallel means in a little bit, to the x-axis, which by the way, after this you're going to realize that the x-axis is the line y equals 0. Sometimes you can have a horizontal line moving through B that has zero steepness. It never rises or falls. And basically what that means is we have y equals mx plus b, where m equals 0. So this means that we have y equals b. And this is the equation for a horizontal line. So you can have positive slope, it'll move up as you go from left to right. Negative slope moves down as you go from left to right. If it's flat, horizontal, it doesn't rise or fall. We call that a horizontal line. Horizontal lines have equations y equal a constant. We also have another situation. So this is when the rise is 0. Sometimes you can actually have the run being 0. So you have a line that's parallel to the y-axis. Let's say that's passing through C. So this line is strange. It cannot be written in y equals mx plus b form, since division by 0 would occur. So there's actually no way to write it in that form. Equations of this form look like x equals c. And that's called a vertical line. And it's the vertical line passing through c on the x-axis. So positive slope, negative slope, horizontal or 0 slope, and this is just no slope. So this is no slope. Some people might describe this as undefined slope. So this guy represents a line with positive slope. This guy represents a line with negative slope. This guy represents a line with 0 slope. So that's important. What else is important to tell you about lines? Parallel and perpendicular probably. So, two lines are parallel if they have the same slope. So, i.e. y equals or both are vertical for the vertical line case. So x equals c is parallel 2x equals d for any constant c or d. And y equals m1 x plus b1 and y equals m2 x plus b2 are parallel if m1 equals m2. So having the same slope means they are parallel. Parallel lines will either never intersect or always intersect, at least in our version of geometry, which is called Euclidean geometry. Non-Euclidean geometry can get a little bit what else? Two lines are what we call, so this is defining the word parallel. Two lines are what we call perpendicular. If one is vertical while the other is horizontal, or they meet at 90 degrees otherwise. Now, how do we know that two lines would meet at 90 degrees? So let's say here's a line, call it y1 equals m1 x plus b1. Here's another line, y2 equals m2 x plus b2. For simplicity, let's shift them to the origin so that they intersect at the origin. It's the xy plane, xy axis. So let's move them so that the y-intercepts are 0. So we have these two lines. Here's something you can do. Pick the coordinate 1 here, move up here, plug in x equals 1, you get this would be the coordinate 1 comma m1 and m2 because it's for this thing. And then over here, you'd have the coordinate 1 comma m1. Notice here that we can actually create two right triangles. When this is going to be a right triangle. Pythagoras' theorem is going to tell us a bunch of things here. The length here is 1, the height here is m2, the height here is m1, the length here is 1. Pythagoras' theorem is going to tell us that this is the square root of m2 plus 1 squared, and this is going to be m1 squared plus 1 by Pythagoras' theorem. And so, by Pythagoras, this squared plus that squared is equal to this squared. So if I call this O, call that A, call that B, Pythagoras says AB squared is going to be equal to OA squared plus OB squared. AB is M1 plus M2. OA is this guy, square that. OB is this guy, square that. Expand this using the formula A plus B all squared is A squared plus 2AB plus B squared. And so this is going to be M M2 squared plus M1 squared plus 2. Subtract this from both sides. Oh, sorry. This is actually M2 minus M1. It's a vertical distance. So this would be a minus. Now what you're going to have is you're going to have minus 2 M1 M2 is equal to 2, or M1 M2 is equal to minus 1. So this means your M1 is going to be minus 1 over M2. This characterizes perpendicular lines, so you can realize that the product of the slopes is minus 1. i.e. M1 would be minus 1 over M2, or M1 times M2 would be minus 1. So two lines are parallel if they have the same slope. Two lines are perpendicular if the product of their slope is minus 1. Or one is horizontal and the other is vertical. So we'll stop there. Next time I'll give you some examples with lines and we will get into graphing. I want to say graphing. Yeah, maybe we'll talk about graphing next time too. Go back to basics. Send an email. Yeah, but an email about the
Yeah，咱们出的时候第一次讲，讨论这个